this LRU algorithm is this one. I'm going to take here. I'm going to take here example from here. You see. So 7 is kept initially. This is one page fault. 0 is coming after 7. One page fault. 1 is coming after 0. It is page fault. Okay, 3 page faults occurred. That is that was occurred for the case of FIFO and for the case of optimal also. Okay. Now 2 came. 2 is not present. 2 is not present in this frame 701. So we have to replace. Now this LRU concept. So optimal means what? Means that the page will not come in the future or come later in the future. Okay. And LRU means that it is telling that least recently used. See that 1 is just used here. 0 is just used here. The least recently used was actually 7. Okay, 7 is used very earlier. Okay, so we are actually going for the concept that is the page that came very earlier, that will be taken as the victim and that will be replaced with the new page. So this 2 will be replaced with the 7 because 7 came very earlier. Okay. Next 0 came, so 0 is the hit here, therefore 0 will not be actually page fault. Next 3 will come. Now among this 2, 0 and 1, which one came earlier? So 0 came just now, 2 came before that, then 1 came very earlier. So this 1 will be replaced with this 3. Any question, anyone here in this part?
No, sir.
Okay, so this 2, 0, 3 came now. Now 0 is the hit. 0 came 0 present already. Okay, so this will not be the page fault. Next 4 is not present in this particular frame. Okay, 2, 0 and 3 is here only. Now 4 will be replaced with what? You see that 0 came before 4, 3 came before that, and then 2 came very earlier. Okay, among these 2, 0 and 3, 2 came very earlier. Therefore in place of 2 we have to keep 4. So 4, 0, 3 will be there. Okay, clear? Next 2 is coming, so 2 is not present in this 403. Now we have to replace. You see that before 2 the elements are present here, that is 4, 0 and 3. The farthest, I mean the earlier one is the, or earliest one is the 3. So we have to replace 3 with 2, therefore 402 will come. Okay. Next 3 is coming. So before 3 the element that are present here, that is 042, and among them the earliest one is the 0. Therefore in place of 0 we have to keep the value 3. So 432 came. Okay. Now 0, for the 0 we have the elements 3, 2 and 4. Among them the earliest one is 4. So therefore in place of 4 0 will come, 032. Next 2 pages are hit because 3 and 2 are present here. 1 is coming, so that among the pages this 032, you see that before 1 the earliest one is 0 here. This 0 will be replaced with this 1, therefore 132. Then 2 is the hit here, therefore 2 will not be the page fault, and 0 is coming here. So 0 will be replaced with what? You see that before 0 the element that are present here 2, 1 and 3. 3 is the earliest one, therefore 3 will be replaced with 0. So 102 is coming here. Now 1 is the page hit and then 7 is not the page hit. This is the page fault, so we have to replace. Now before 7 the pages that came here, that is 0, 1 and 2, among them 2 is the earliest one. So 2 will be replaced with 7. So 107. Then 0 and 1 is the that is the page hit. Okay. So if we count the number of page fault, then that is 4, then 5, 6, 7, 8, 9, 10, 11, 12. 12 number of page fault is here. So FIFO was having 17 number of page fault. In LRU it is having 12 number of page fault, and in optimal it is having 9 number of page faults for the same reference string. Okay, therefore you can say that LRU is having optimal is having much more performance than the LRU and the FIFO. Okay, so in this way you can solve the problem. So generally I will give a question that is having 3 frames, this 3 frame size and the reference bit string. You have to find the number of page faults. If you have any question you can tell me. Any question from this part? Now one important thing is there, that is called the Belardis anomaly. Okay, or anomaly. So Belardis anomaly means that generally this thing happens if we increase the number of frame size. Like initially here we are taking 3 number of frames. We may also do the program or do the problem solving by using 4 number of frame also. Okay, also by 5 number of frame also. So if we increase the number of frames, generally number of page fault will decrease. Okay, but sometimes this may happen that number of page fault will increase. Okay, so what is our objective actually? Objective is that to decrease the page fault. Okay, so if we can if the number of page, so if the number of page frames are actually increased here in this way, then the page fault performance actually is decreasing here. Okay, so this may happen. This is called the Belardis anomaly, that generally if we increase the number of frames, page fault will decrease, but sometimes this happens that after certain time if we increase the number of frame, then the page fault will increase. Okay, that is called the Belardis anomaly. Okay, these things should be studied. So you just go for the from this chapter I am telling you, you just go for this particular problem solving that I have taught, okay, today. Then the page replacement algorithm, what is the requirement, segmentation, demand paging, lazy swapper, virtual memory, and paging concept, then TLB. This TLB is here, yes, this one, translation look aside buffer, TLB, this is important. Then the concept, that is paging is already told to you. Fragmentation, internal fragmentation and external fragmentation with figure, with diagram, this diagram, and the memory management unit and its working, physical address space, logical address space. Yes, this thing only. Okay, so in today's problem solving, any question, any one of you can tell. Hello, hello, can you hear me?
Yes, sir.
Okay, so
Yes,
any
sir.
question in today's class?
No, sir.
So you just practice that one very well. Okay, so I will give that question. I told you already, I have given, therefore I am telling you. So I taught this thing, and if the next class is there, then I will go for the remedial classes or the previous classes. So up to this it is complete. Okay, the question
sir.
will come up to this part, up to this memory part. Okay, so just study very carefully, solve different problems. CPU scheduling problems will come, deadlock problems will come, then the algorithm that are taught in, I mean the problem solving that are taught in the chapter of synchronization, that will come. Semaphore is very important there, and the race condition and the critical section problem, that will come, and also the question that is come from the memory that I have told today, that thing that will come. And yeah, so this question will come. Okay, you have to solve. And yeah, and the fork join problem and co-begin co-end problem will also come. Okay, that will practice very well. Okay.
Yes, sir.
Okay.
Yes, sir.
Okay, and I have given the solution of the different the lab question I have given from 25 to 30. Okay, in the group I have given. So you write that one, you practice that one in your home. Okay, so up to 30 question will come, and lab examination will be probably in the next week, that we will declare. The schedule will be given on Monday. Okay, so you practice very well. You have to answer 2 questions. Okay.
Okay, sir.
Okay. Okay, so I'm going to end the class.
Thank you, sir.
Okay.